Hello, welcome to Maths with EJD. In this video, I'll be talking about the Fourier transform. It's under Fourier series, under sequences and series. Although I make Fourier series into a different playlist, but I'll add it to the playlist for sequences and series. So you can see them as two different playlists like that, and you still have Fourier series in both. All right. So for the Fourier transform in this case, what is this about? So let's start with the key concept of the Fourier transform. So first off, the Fourier transform it generalizes the Fourier series. It generalizes the Fourier series to non-periodic functions. So we know generally that periodic functions basically transform periodic functions. I mean, Fourier series translates periodic functions into sums of sines and cosines. But what the Fourier transform does is to generalize the Fourier series to non-periodic functions, so such that it can convert. So converting a function f of x, converting the function f of x in the time domain, in the time domain. So in the time domain into its frequency domain, into its frequency domain. So that's what Fourier transform does. So you take a function f of x in the time domain to a frequency domain. So small f of x is the time domain. Frequency domain is big F of k now. So, and that representation is something like this. So you have big F of k is simply summation from minus infinity to infinity of this time domain f of x e raised to minus ikx dx. Minus ikx dx. So again, don't forget, this is the time domain. Small f of x is the time domain. So when you throw that into this integration, it outputs this frequency domain, like this. Okay. Now, to drive the point home, can we take an example? So we have this example here. We want to find the Fourier transform. Find the Fourier transform of f of x, which is equal to e raised to minus a. Okay, let me bring that down to make it clearer. The Fourier transform of f of x, which is equal to e raised to minus a absolute value of x, where a is greater than 0. Okay, that's what we want to do right here. So here, the first thing we want to do is to set up the integral. Set up step 1, set up the integral. Okay. And to set up the integral, we already know using the Fourier transform formula, okay, we have that f of k is equal to integral from minus infinity to infinity, e raised power minus a absolute value of x, then multiplied by e raised power minus ikx dx. Of course, that's stemming from the general expression we have from here. Okay, so we have this, and from there we have to elaborate. So we have big F of k now. Big F of k is equal to summation from minus infinity, integral from minus infinity to 0 of, we can tidy up all of this using the rules of indices, right? And of course, the absolute value of x, you can actually have it both on the positive and the negative side of things. Okay, so this can become e raised power minus, okay, e raised to power a minus ik e raised to power a minus ik x out here, all right, because of this k dx. We have it on that side, and then the other part is integral. So from 0 to infinity. The absolute value of x means that x can take both negative or positive values. So for the negative side of things, okay, I guess I should carefully or maybe this explanation should suffice, right? So absolute value of x means that x is every value from minus infinity to infinity. So I think this should be fine. So if we take it from minus infinity to 0 now, it means we are talking about the negative x. Okay. So in that case now, that was okay. Let me not be in a hurry. Let me take it carefully. So if we break it down, so from minus, everything is from minus infinity to infinity. So if you take from minus infinity to 0 now, so we are saying that x, this absolute value of x, takes only positive values. I mean, it takes negative values. So we have minus e raised to power minus a times minus x. All right. That's between minus infinity to this. Then that multiplied by minus e raised to power minus ikx dx. That's one side. The second side is from 0 to infinity now. So we now have e raised to power minus a multiplied by positive x. Then we now have e raised to power minus ikx dx. That's basically what we are saying here. So it means that f of k is infinity from integral from minus infinity to 0 of e raised to power ax multiplied by e raised to power minus kx dx plus integral from 0 to infinity e raised to power minus ax e raised to power minus ikx dx. That's what is basically happening there. Okay. Because absolute value can be negative, it means x can have negative values or positive values. It has negative values from minus infinity to 0, but positive values from 0 to infinity. And that's exactly the idea we have going on there. So we can tidy this up further. Let me just switch things up. So we can tidy this up further now and say we have f of k to be integral from minus infinity to 0 of e raised to power, ax minus ikx. So x is common. So we have e raised to power a minus ik into x, all right, dx, plus integral from 0 to infinity. Then now we have e raised to power, minus can be outside now, minus a, all right, plus ik x is out now, dx. So that's the kind of thing we have going on in that place now. So the next thing is to evaluate each part. If you want to say that, take that as some kind of step 2. So we evaluate each part. So we have this now, right? More concise. So the next thing is to evaluate each part. Step 2, evaluate each part. So to evaluate each part, so I'm just going to, so we have for x belonging to minus infinity to 0 now. That's the first part now. So we can easily integrate that. That shouldn't be a problem. So, it means we have integral from minus infinity to 0 of e raised to power e raised to power a minus ik x dx. So if you integrate this, it's pretty easy. So differentiate, you substitute, take this part out. So it's simply just going to be 1 over a minus ik. That's what that integral is going to give us. Okay. Because basically what we're supposed to do is we say, or should I just go explicitly? Yeah, I've done integration in the past. So basically, we're supposed to say something like, let u be a raised by minus ik, or you just take that part out, and we know that we are going to have this exactly the same thing divided by itself. And then if we substitute minus infinity to 0, we end up having 1 over a minus ik. So you can tidy that up also. So on the other hand, if you have if you now have for x belonging to 0 to infinity, that's the second part. This is this second side of things now. So you have integral from 0 to infinity, e raised power minus a plus ikx, a plus ikx dx, a plus ikx dx. This can be neater. So we have a plus ikx dx. So if you do that also, here you got 1 over a minus ik here. So you're going to have 1 over a plus ik. Okay, 1 over a plus ik. So the last thing we just need to do is to combine the results. Okay, combine results. That's like step 3, right? Step 3, combine results. Combine results. So in that case, sorry, my perfectionistic trouble is raging here. Right. So let me go green. So combine results. Combine results. So that means our f of k is simply 1 over the first part, 1 over a minus ik plus 1 over a plus ik. Interestingly, under mental math trick, you already know this is like difference of two squares. So you can tidy things up. So LCM of this is simply a minus ik into a plus ik. So a minus ik here, so you have a plus ik plus a plus ik here, you have a minus ik, So that means you have a plus ik plus a minus ik. So ik cancels ik all over. Of course, this is now difference of two squared. That's a squared minus ik squared. Okay, a squared minus ik squared. So we can tidy all of that up, and that is equal to a plus a is 2a, and down there you have a squared a squared minus I squared k squared. And you already know from complex number, right? From complex number, I squared is 1. I squared is minus 1, so you have 2a plus a squared minus k squared, because I squared is minus 1, because I is square root of for reminder, I also have a playlist on complex number, so this is I, so this implies that I squared is minus 1 all squared. So I squared is simply minus 1. So the minus 1 comes in here now, so that f of k is simply 2a over a squared plus k squared. And that is the idea of Fourier transform. So x squared in Fourier transform becomes all of that. All right, that's what e raised power minus a absolute value of x, not x squared, sorry. So that is what that becomes. So I can just say, therefore, for f of x equals e raised power minus a absolute value of x, for f of x raised to power, for f of x equals e raised power minus a absolute value of x in the time domain, okay, we have f of k equals 2a over a squared plus k squared, all right, in the frequency domain, basically. That's what Fourier transform does. Takes a function from the time domain to the frequency domain, basically. In the next video, I think I'll be talking about discrete Fourier transform. Discrete Fourier transform. That's what I'll be talking about in the next video. All right. So watch out for that. If you have not subscribed to the channel, you don't want to miss out on that. So be sure to subscribe right away. and hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know how helpful these videos are for you. Let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. Like and share so that more people can have access to these great teachings. Bye.